In this section, we will be discussing network terms and communications between computers. Let's look at the different types of networks that we will be discussing throughout this course. Local area network, wide area network, metropolitan area network, and storage area network. Now, most people are familiar with what a local area network is. Here is a diagram of a small single segment local area network. This is something that you might find at one classroom here at CCBC. Now, this is a diagram of a larger local area network. This is a diagram of the network at the CCBC Catonsville campus, and this is called a multi-segment local area network because you can see that each building has its own local area network and they are all tied together. In one building we've got a switch and all the computers are tied into it. Another building we have a switch which has the computers tied into it. And then we have the data center, which is in another building. They're all connected to the router, which connects us to the firewall, which connects us to the internet. This would be a large local area network. Sometimes they call it a CAN, a campus area network. And it is confined to a single geographic area, typically not more than 1 mile across. So this is a local area network, CCBC Catonsville. At the other extreme, we have a wide area network. And in a wide area network, you have thousands of miles between the nodes. And of course, the internet is a good example of a wide area network. Now, a metropolitan area network is somewhere between a wide area network and a local area network. A metropolitan area network exists within a metropolis, a city. And a perfect example would be Johns Hopkins University. Johns Hopkins University has many buildings throughout the city of Baltimore, and they're all connected with their own network, and that is called a metropolitan area network. Now, another type of network which is totally different is called a storage area network. And a storage area network exists within a server room, or it's within the data center. And in a storage area network, you have the servers, which are connected by way of storage area network switches to a big disk array. And that way, all of the servers can access the same big disk array. We will cover storage area networks in greater detail in Chapter 11. Now let's discuss communication between computers. Let's discuss how one computer can send the number 7 to another computer. Now, computers can only send positive and negative impulses to each other. Computers can only put positive and negative impulses on the wire. And each positive and negative impulses is represented as a 0 or a 1, and these are called bits. We have 8 bits being sent from one computer to the next. So the question is, if a computer can only send positive and negative impulses to another computer, how can it send the number 7? In other words, how come 5 negative impulses and 3 positive impulses equal to the number 7? And the answer is, different combinations of bits represent different values. So then that leads to the question, which combination of bits represents which value? In other words, how come 5 negative impulses and 3 positive impulses represents the number 7? And this leads us to binary math. So remember, one computer sends 8 positive or negative impulses to the other computer. If we jump to Chapter 8 to page 239, we see there is a section on binary math. Binary math shows that of the 8 bits which are being sent from one computer to the other, each one of these 8 bits is a placeholder for a value. And the first placeholder is 1, the second placeholder is 2, followed by 4, 8, 16, 32, 64, and 128. So if one computer sends 7 negative impulses and 1 positive impulse to another computer, it's sending the number 1 because we have 1, 1. If one computer sends 6 negative impulses, a positive impulse and a negative impulse, or you could just say 6 zeros, a 1 and a 0, then that computer is sending the number 2 to the other computer because we have no 1s and a 2. If we have 6 zeros and 2 1s, that's equal to 3 because 1 and 2 is equal to 3. If we have 5 zeros and 3 1s, that's equal to 7 because 1 plus 2 plus 4 is equal to 7. Let's do another example. If we have a 1 followed by 7 zeros, that's equal to 128 because we just have 128. If we have a 1, 6 zeros, and a 1, that's equal to 129 because 1 plus 128 is 129. And if we have 8 1s, that's equal to 255. That's equal to 128 plus 64 plus 32 plus 16 plus 8 plus 2 plus 4 plus 2 plus 1, and that's all equal to 255. When you have 8 1s, that is equal to 255. Here's some other examples. 6 zeros and 2 1s is equal to 3 because we've got a 1 and a 2. 4 zeros followed by 3 1s is equal to 7 because we have 1 plus 2 plus 4. If we have 4 zeros and 4 1s, that's equal to 15, which is 1 plus 2 plus 4 plus 8. Now let's look at the higher order bits. If we have 2 1s and 6 zeros, that's equal to 192, which is 128 plus 64. 3 1s followed by 5 zeros is equal to 224 because that's 128 plus 64 plus 32. 4 1s followed by 4 zeros is equal to 240 because that's 128 plus 64 plus 32 plus 16. Now notice if we have 4 zeros and 4 1s, that's equal to 15. But if we have 4 1s and 4 zeros, that's equal to 240. These are 4 lower order bits, and these 4 1s are the higher order bits. So let's get back to the communication between computers. How can one computer send the number 7 to another computer? Computers can only send positive and negative impulses over the wire, which are represented as zeros and 1s, and they are called bits. There are 8 bits in 1 byte. And different combinations of bits represent different values. That's how 5 negative impulses and 3 positive impulses can equal the number 7. Now, let's talk about what a packet is. A packet is a message which is being sent from one computer to the other. If Workstation 3 wants to send the number 7 to Workstation 1, it will send a packet. And a packet has 2 main components. It has the data and the header. The data is the number that we want to send from one computer to the next, just the number 7. And the header shows who the packet is going to. This indicates that the number 7 is being sent to Workstation 1. Well, this is how we diagram it. But here's how the computer sees it. The computer sees it as the header being 7 zeros and a 1, meaning it's going to Workstation 1, and the data portion is 5 zeros and 3 1s, which is the number 7. This is looking at packets in binary, and of course we will talk about binary in greater detail in Chapter 6. Now let's talk about examining traffic between computers. A protocol analyzer is a piece of software that allows us to examine all packets which are being sent and received over the wires. And common protocol analyzers include Sniffer and Wireshark, and that's what we use here at CCBC. A protocol analyzer is a piece of software that allows us to listen to all network traffic. And good guys use protocol analyzers to fix network problems. We certainly use it here. and bad guys use protocol analyzers to eavesdrop to steal credit card numbers and passwords, and that's why we use encryption. Here is the Wireshark protocol analyzer, and here it's simply showing us that network utilization is about 50%, and it's jumped to 100%, and then it goes down to 0%. But that's just overall network utilization. Now, to look at the individual packets, here's another protocol analyzer called Microsoft Network Monitor. And this allows us to look at every packet which has gone over the wire, the source IP address, the destination IP address, and the contents of the packet. Protocol analysis will be covered in greater detail in Chapter 13. In summary, in Chapter 1, we looked at the components of a personal computer and the components of a local area network. We looked at peer-to-peer networks and server-based networks, and we saw that the type of servers in server-based networks include file servers, print servers, domain controllers, and many others. We looked at different types of networks: local area network, metropolitan, wide area network, metropolitan area network, and storage area network. We saw that a packet is a message which is being sent from one computer to the other, and that computers communicate to each other using binary. This concludes Chapter 1. Thank you very much, and have a nice day.